Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about how do you find whether the function is an increasing function or it's a decreasing function using derivatives. So we're going to be using derivatives to actually find that. So let's go ahead and get started. Uh, Now, how do you find how do you find that? Before that, I'm going to actually define. You've actually seen the previous derivative videos or differentiation videos. Now I'm going to define that again, in the same context but in a very simple manner. Now the derivative of any function is actually it's actually equal to the tangent of the angle that the let's suppose if I have this function here, I want to find the derivative of this function at this point. That will actually be the tangent of this line, that will actually be the slope of this line, or tangent theta that the line makes with the x-axis. That means that the derivative is completely dependent on the slope of the line. Now if that means from here what we can actually say that if the function is increasing, so if the function is increasing, let's say at point A, so if the function is increasing at point A, then the derivative at A is actually going to be greater than 0. And if the function is decreasing at point A, so if the function is decreasing at point A, then the derivative of that function is actually going to be less than 0, because if let's suppose the function is decreasing, then if this is a decreasing function, this at this point the function is decreasing. So if you find the slope of this line, the slope of this line is actually going to be negative. Fine. So I suppose you're understanding this point over here, and if the derivative is equal to 0, then that means the function is supposed to be stationary at that point, right? So if the derivative is 0, is actually going to be stationary at that point. Now let's go ahead and formally define what we've just said here, right? So let's suppose if you have an increasing function from interval a to b. So let's suppose you have a function here, and it's an increasing function. From a to b, it's actually an increasing function, right? So if you have an increasing function, so I'm formally defining what I just said, from a to b, right? And x1 and x2 are the values which actually lie between the x1 and x2 values are actually which lie between a and b. So x1 and x2 are some values here, right? Now another thing is that if let's suppose x2 is greater than x1 and f of x2 is also greater than f of x1, that actually means that the function is increasing, right? So if x2 is greater than x1, so let's suppose this is x1 and this is x2. So if x2 is greater than x1, then the function of x2 is also greater than the function of x1. That means that the gradient of the gradient of f at any value between here x, at any value here x, is actually going to be greater than 0. Fine. And if I have a function which is, let's say, decreasing function, let's suppose this is a decreasing function, then the gradient over here is actually going to be less than 0. And let's suppose if I have a function like this, let's suppose if I have this function, then at till this point, the function is an increasing function, right? So till this point the gradient is greater than 0. After this point the gradient is less than 0, and at the tip, at the highest point, the gradient is actually going to be equal to 0, right? I can even say gradient, I can even say derivative, I can even say the differentiated value. Fine. So suppose you're understanding this point over here. Let's take an example. Let's suppose if we have a function, let's say f of x is actually equal to x cubed plus 24x plus 3, and x belongs to all real numbers. Now, I want to show that it is actually a real function, an increasing function, right? So I want to show that this is something which is an increasing function. So the derivative of x is actually going to be equal to 3x squared plus 24. If you see that this 3 will come here, and you'll have x square, and this is equal to 24, right? So this is just the derivative of that function. Now, as you know that x square is always positive, right? X square is always positive or 0, right? And 24 is a constant which is positive, which means f dash of x will always be greater than 0. That means f of x is an increasing function. So f of x is an increasing function. Fine. So suppose you're understanding this point over here. Let's move forward to the next question. Now let's suppose if I want to show that for what values of x, so for what values of x will f of x equals to x cubed plus 3x square minus 9x is a decreasing function. Let's suppose I want to show that. So I have to find the values of x where this is actually a decreasing function. So how will I find that? So first I'll find the derivative of x, which is actually going to be equal to 3x square plus 6x minus 9, right? Which is actually equal to 3 times x square plus 2x minus 3. Now, which is actually equal to, so if I just kind of solve this up, this actually becomes 3 times 1 and x square plus 3x minus x minus 3, which is actually equal to 3 times x plus 3 and x minus 1. Now I want to find for what values is this a decreasing function. So for a function to be decreasing, f dash of x has to be less than 0, which means this value over here will have to be less than 0. So 3 into x plus 3 into x minus 1 will have to be less than 0. Now how do I find those values? Now this is actually a quadratic function, isn't it? Right? So which is actually going to be something like this. And at what value is this function going to be equal to 0? At x equals to negative 3 or at x equals to 1, this function is going to be 0, because if this is 0, x is negative 3. If this is 0, x is 1. So at negative 3 and at 1, this function is actually going to be equal to 0. And since the coefficient of x square is positive, this function is actually going to be looking like this. It's not going to be inverted, it's going to be like this, because x into x is giving me positive. Now for what values of x this function is less than 0? So this function is actually less than 0 for these values. What are these values? These values are greater than minus 3 and less than 1. Right? So for these values, the function is actually going to be a decreasing function. So I suppose you're understanding this point over here, guys. So for these values, the function is actually a decreasing function, right? So as you can clearly see in this graph over here, that the function is actually decreasing. Uh, and understand, this does not represent this function here, right? This is a totally different function. Is this just represents this derivative, right? So for these values, this is actually going to be a decreasing function, not this one, right? So don't go by this one. This is actually going to be a decreasing function. Fine. So I suppose you're understanding this point over here, guys. So thank you very much for watching this video. And the next video, we're going to be finding out uh, how to find out the stationary point, the minimum point, maximum point, and the point of inflection using the double derivatives. Right. So before we depart, guys, make sure that you visit our website, that is perfect-scores.com. A lot of exciting stuff here. Don't forget to explore that. Don't forget to like us and follow us on Twitter, and give us your valuable like and feedback on perfectscores89 at gmail.com. So thank you very much for watching, guys, and I'll see you in